Okay, I'm going to do an initial reaction to the paper that's just been published now. That was, so the higher level maths paper 2022, that was just finished about a few minutes ago. And then in a later video I'm going to go through I'm going to do all the questions out. And I'll probably do some more videos for physics and applied maths this year, maybe some others. And one thought I had is I might even put this one side by side with the maths paper that I did and just see what the comparisons are. But so let's just have a quick view of paper 2. I think the general consensus paper 1 was fair enough. Let's have a look at this one. Okay, so 2.5 hours for it. And so section A. Okay, so concepts and skills. Question 1 looks like probability. Okay, so fill in missing values to complete the table. Okay, so it looks like, I mean, I know they're trying to ease in on these things, but that is some easing in, because it looks like it's basically addition and subtraction for that one, which is a nice way to ease people in, so that is lovely. Student picked randomly. Are the events O and U independent? Okay, that's a nice one, and that's something that I predicted actually, because last night I did focused on dependent and independence over the weekend, and yeah, and that's an interesting one. So really, if they're independent, you'll have to work out the probability of O, probability of U, and then work out the probability of O given that U has happened. And if the probability of O given that U has happened is equal to the probability of O, then they're independent. And I'm guessing there in this case that they're dependent, but I'll have a look later. 3 people picked at random, probability they're all born the same day. That's a fairly standard probability question. It looks okay. Okay, number of girls joined the class, picked at random from the probability the girl is now this. So that's a fair enough question. I mean, all of those are just going to boil down to simultaneous equation, putting in some variables and putting the standard probability equations and creating some simultaneous equations for yourself. Okay, so point A, B, endpoints, coordinate C, split internally in the ratio of 4:1. That is fine. You just get the log tables thing for, there's a log tables question or formula for splitting a line in a ratio. So put in your A and B is 4 and 1, and that should be okay. L is a slope M, find the coordinates point which cuts the x-axis. Yeah, so I suppose the point at which it cuts the x-axis, if you let that be, so that's going to be 0C, let's say, and then get the slope between 0C and QR in terms of those, and then your line will be y is equal to mx plus c. Okay, so in terms of m, q, r, q and r, okay. Yeah, so that should be fairly straightforward. And k is a slope this, line j is an angle 30, one possible value of the slope of the line j. Okay, so you can get your slope, oh yeah, your formula for the angle, tan of the angle between two lines, given a slope m1 and m2 of the lines, bang that in there, and that will give you the slope between the two lines, well, the tan of the angle between the two lines, so it's the tan of 30. So that will give you the slope of the other line. That should be fair enough. C has this, radius is that, find the value of k. Okay, so okay, that's very fair. Yeah, so the radius is 1 minus 4, and then your center is 1 minus 4. Your radius then is g square root of g squared plus f squared minus c. So I'll just pop that in there and you should be able to get k, fair enough. Circle has a tangent at this point, find the slope of the tangent. Okay, so your center of that circle there is 5 minus 2. The tangent is at the point there, so if you get the slope of the line between the center and that point, and then it's the and then use it's perpendicular to that, so m1 by m2 is equal to minus 1. That should be all right. Circles there contains the point. Yeah, equation of each of these circles. Yeah, I did a similar one of those over the weekend actually. In fact, it's very similar to that. So that's reasonably okay, but it does take a little bit of working out, and I'll work that out later on in the next video. Prove that tan A minus B is equal to tan A minus tan B over that. Yeah, I mean, the problem with these ones is kind of where to start, because, you know, you're given, yeah, like there, that's where it is in the log table. So it's a question of where to start. And I presume you could just start with this. So sine A minus B is equal to this. Cos A minus B is equal to that. And then use cancellation. So if that's flipped over, you would use cancellation then to probably dividing above and below by cos A, cos B, and that'll get that. Either way, it says probably one or two lines. It should be fairly straightforward. And now write tan 15 in the form of these surds. So presumably, even though they're not saying it, they're implying that you have to use that formula. Well, I mean, you probably don't have to, but it would be difficult to get it in surd format otherwise. And that kind of awkward surd format. So, okay, so you'd have to find two angles. So like say 45 and say 50 and 30. Subtracted together gets you 15. So 45 and 30, yeah. So tan of 45 would be 1. Tan of 30 is what? 1 over root 3. Yeah, so you'll get your surds popping out in that. Yeah. There's probably other angles that you could take as well. Triangle ABC, that is equal to that. So that's an isosceles triangle, so that angle is going to be equal to that. That's 45, you know this. Find the length AC. Find that length AC. This looks like a cosine rule, Yoki. Yeah, so yeah, pop it into the cosine rule and that should be fine. And nice, and the cosine of 45 is what? 1 over root 2, so it probably simplifies all those. That's the first time I've ever seen a root of a root in a Leaving Cert paper, so it's just mixing it up a little bit there. Survey of learning. Okay, I'm gonna skip over that one. Circumcenter, oh yeah, so I was anticipating circumcenters and orthocenters coming up, so happy to see that coming up. Compass and straight edge, okay, label a circumcenter, yeah, so that should be fairly okay. Now it is annoying that, I mean, it's probably a little bit, that's the one question which I find a little bit unfair for people who aren't anticipating that question to come up, because these orthocenters, circumcenters, incenters, they're not in the log tables, so you have to know them off by heart. And really, it's just putting a weight to knowing what a name means rather than what it actually does. I may only make a bit with that, but otherwise it should be straightforward. Okay, AB is the diameter of the circle, ADAC is 40, ABC is isosceles. No, ABD is isosceles. Well, okay, so that's an angle in a semicircle, so that angle there will be 90 degrees for starters, and that should be fairly easy, I think, to work out. Okay, triangle in a circle. Again, this is not on a semicircle now. So K is the circumcircle of P, Q, and R, okay. O is the circumcenter. Prove that O cannot be inside the triangle. Okay, so that's that's going to test people, I think. And that's and then proof by, they're bringing in the proof by contradiction, which we haven't seen in a while. Normally it's prove root 2 isn't rational, so that's interesting. And I'll do that later. Okay, standard volume question. Okay, that's pretty straightforward. So your volume is pi r squared h, you know that, so it's 100 pi h is equal to this. So h is what, is it 4.5? Yeah, okay, large candle cone, radius, yeah, so they like those kind of questions where you have a ratio between the radii or something like that, and then how does that relate to the volume ratio. And it's interesting. Third conical candle is curved surface area covered in cloth. The net of the cloth, okay, we haven't seen nets in quite a while, and that was a junior cert area, so I'm surprised to see that. So that might throw people a little bit. Okay, length of the arc from B to A in terms of pi, hence find the radius cone. Okay, so I'd say that will probably throw some people because you probably wouldn't have seen it since the junior cert, and that will probably be tricky for people, I'd say. But otherwise, okay, wax spherical ball. Okay, that should be fine. Radius of a sphere. So you have that in the log tables. Now they're making it a little bit more complicated here. Circular base. Okay. Okay, so that'll just test people a little bit more on that one. And this is your standard kind of working out angles and sides one. But so that these ones do take a bit of plugging away and just finding out what's what equal triangles. But I'd say once you persevere at that one, that's okay. Fuel consumption in cars. So they love being kind of topical with these things. So this is nice and topical. So maths is getting all kind of morphing into applied maths, and then meanwhile applied maths is kind of going in a kind of a bonkers direction. Okay, so researching scatter plot. Okay, so do scatter plot there and identify on the scatter plot. That should be fairly straightforward. Try to pick out which ones these are. Just using x and y coordinates, that's grand. I don't think that should be a problem for people. Draw the line of best fit for the data by eye. Okay, now that is a good question. I would say, it'd be considered a good practical kind of question and not easy. And it's difficult to say what 100% would be. Strictly speaking, and this is beyond the scope of the course, but the line of best fit is such that the square of the error, the sum of the squares of the errors is minimized. So the absolute sum of the squares of the absolute value of the errors is minimized. So basically what you're trying to do is you're trying to put a line there such that the distance that each point is off the line in absolute value summed all together is at a minimum. Usually you're just trying to get it through the mob there so that there's an even scattering around the line. So that's a good question. It's a practical one, and but it might be tricky for people, I think. Would you be more confident the value for K or L? Now that's a fairly interesting question. Never seen anything like that before. It's almost like your own personal input into it is deciding it, which is a nice kind of practical way of doing it. Now, in reality, it's not. I'd say there is a right and a wrong answer. I'm guessing, okay, the city car is 20. You have a plot there that's around 20 already, and it's nice and bunched in with the rest of them. I'm guessing that that's the one you'd be more comfortable with rather than, what's that, motorway 60. So that would be up here and cutting the line somewhere up here, very far away. It's an outlier from the bunch. So I'm guessing that would be the most confident, but they're kind of giving you a personal input, and as long as you make a good case there, you're okay. Correlation coefficient between city and motorway miles per gallon, that should be fine. And then correlation coefficient again for F and S, where it's very close to 0, that should be okay as well. 13 customers giving rating in a garage. Okay, so ratings. Okay, so the M and S are the ones you don't know. Find the least value and the greatest value that S could be. So that's an interesting one. And again, a bit of a challenge. I'd say the very first thing you have to do is reorder this. Now the question is, how do you reorder them when you don't know these guys? But you know that the median score is 54. So this guy has to be 7th. So okay, there are two possible values. One is where S is down in the lower quartile and M is up in the other quartile, and the others where they're flipped. So yeah, so that would be the way you do it. So if S is down there, the least value that S could be is where it's as low as possible in the lower value in that quartile, while M is way up there. And you also have a value for the mean. So add them all up and divide by 13, and you'll probably end up with an S plus M is equal to the total of all this multiplied by 13. So you get an equation for S plus M. So, and your two possibilities, S is down the lower end, M is up the other end, and vice versa. And given the relationship between S and M, you can find out your least and min, max and min. Okay, probability, head gasket flows. Okay, that's your expected value. They're usually reasonably good. So you're just multiplying your probability by whatever costs it costs. And that's a nice practical one. So if you are going into a garage, you might be mentally making these kind of questions. Probably at least one of the events happens, taking them to be independent. Okay, and that's a reasonably okay one as well. Probably a little bit harder than the other one. Okay, so on to geometry and trig. The fields of Athenry. So area of field 1. It's like a one I did over the weekend, actually preparing for this. Area of field 1, I'd say you'd be using that one with the sign. So the area is equal to the half of the product of two sides by the sine of the internal angle for field 1. Hence the area of field 2. Well, you could use the same formula. So area is equal to the half of the product of that by that, sine this C. Length of the perimeter of field 1. So, excuse me. So you're going to need that. They helpfully say that's not a right angle triangle, which they didn't do in a previous year, about 2 years ago. It looked very right angle. But that would be, so I'd presume cosine rule. So to get that, and then you just add them all up to get the perimeter. Okay. Is this the same question? Okay, this seems like a longish one. Okay. Sound travels at the speed of sound. Air travels. Use the information in diagram 1. Show that it takes 41 seconds for the airplane. Correct in a near second. Okay, so the airplane's traveling this way. The sound is going to travel this way. That's 45 degree, that's 90, so that's 45 as well. So it's a 45 triangle. So the sides are going to be equal. So it's going to be 1, 1, root 2 triangle. So that's going to be 10, that's going to be 10, and that's going to be root 2 of 10. So, how long does it take? Well, speed is equal to distance over time. So time is equal to distance over speed. So it's that distance, which is 10 root 2 over the speed of sound, which is 343. The plane is traveling at that speed. It's flown to that. Okay, so what's that angle? Well, I think you just need that gap distance there first. So it says by the time Oscar hears the sound, what that's effectively saying is the time is the same for that to travel there and for that to travel there. So it would be that time, which you already have. Okay, so you already have that 41 seconds. And you're now saying that goes there, so it's the plane, so it's the 41 seconds over the speed of the plane, which is 255, would be the distance that that's travelled. You know that that's 10, so subtract the 10 to get this little gap. You know that, so you can get tan, so you now know tan inverse of the angle to get the angle. Okay, this guy, plane is falling to point P. Okay, explain why that equation holds. Well, by the time Oscar hears the sound, the plane made at P3, plane is flown out to P4, so that's a critical one. So what they're effectively saying, rephrasing it, is that the time taken for the sound to travel there is the same time that the plane goes from P3 to P4. So time for the sound is equal to the time for the plane. So time for the plane is equal to the distance over speed. So the distance is 2d over the speed of the plane, which is 255. And the time for the sound is equal to that distance or the speed of sound, which is 343. The distance is equal to 100, so it's the Pythagoras, it's d squared plus 100 squared root. Okay, so that equation holds. Solve the equation for d, correct to that, and that's fairly straightforward. Now you've only one known and one equation, so presume square both sides and you get a quadratic. You might get interesting two values of d maybe, and one will be valid, but we'll see later. Okay, so normally distributed. Okay, that question should be fine. We'll have a look at that later. And that is it. Okay, so overall thoughts on that, I would say that is a fair enough paper. There's maybe 2 or 3 tricky moments in it, but I would say that's a fair enough paper, I would think. Very fair. The field there is field 1, and the plane is, I think it's quite practical and they're quite good questions, but I think they're accessible. The plane bit might be tricky for some people. Probability 1 there, I think it will be okay. I think overall that's a decent paper. In the next video I'm going to do them all out and just see what they look like, crunching the numbers, and probably do the same for applied maths and physics as well.